I'm Anil Kumar sharing with you a test paper on probability. We'll have 7 questions in this test paper and I'll answer them one by one. You can actually pause the video and look at each one of these questions. Here is question number 1, followed by another simple question where we will find the probability of drawing from a deck of cards. Then we will have a probability based question where tree diagram will be used to solve. This will be followed by another question where we will understand how to use Venn diagram and then answer the question. And then we have questions based on permutation and combination. Right, so these are a couple of questions based on permutation and combination, and this will be followed by a thinking question. So I hope you find this set interesting. It'll take about half an hour. So now you can actually pause the video, do them yourself, and then look into my solutions. Let's begin. Question number 1 is, determine the probability in each case. A, obtaining 3 heads in a row, flipping a fair coin 3 times. So it's a fair coin, probability is half for each time. Since they are independent events one after the other, this probability is going to be multiplied. So what you get is 1 over 8, right? So 1 over 2 times 1 over 2 times 1 over 2. Second, drawing a spade or ace with standard deck of cards. Now there are 13 spades card, and how many aces? Well, there are 4 aces. So if you look into this Venn diagram, you know that there is 1 ace of spades which is common, and there are 3 aces plus 1 ace of spade. That makes it 4. As far as the spade cards are concerned, let's call this as spade cards. There are 13 in all, so 1 plus 12. You get an idea, right? So now it says drawing a spade or ace with a standard deck of card is what? So these are all the possibilities, correct? And total is, we know in our sample space we have 52 cards, correct? So the answer here, the probability for spades or ace is equal to. So you could do like this, or you could also do like 13 for the spades plus 4 for the aces and minus 1, which is intersection, divided by 52. So that is the other way of doing it, correct? So here what we are doing is the common part has been taken away since it is added twice. Perfect. So that gives you the answer. So it is 13 plus 3, 16 over 52. Now that could be reduced and should be reduced. Dividing by 4, we get 4 over 13 as our answer. Does make sense to you, right? I'm not explaining much here in this test. I hope you know all the concepts. I'll provide you with the links to go through and understand basic concepts. C, not picking a vowel from the word probability. So how many words are there? So we are saying not vowel. So that means either you could count the vowels and do 1 minus that, or you can count the consonants. So total numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 goes in the denominator. Not vowels means 1, 2, this is a vowel, 3, A is a vowel, 4, I is a vowel, 5, 6, 7, and 8, right? So what we are left with is the numbers which are not vowels, right? So we know A, E, I, O, U. So we'll leave these 4 and count the rest, which are not vowels, which are 1, 2, 3, 4, 5, 6, 7. So it is 7 over 11, which is your answer. So I hope that is very simple. Now let's move on and take up the next question, which is find the probability of drawing 2 face cards in a row. So when I say 2 face cards, we know we have 12 face cards and 52 cards in a deck. So when you are drawing, there are two cases here. One is with replacement, the other one is without replacement. So in the first case, when it is with replacement, since there are 12 face cards, you could do 12 and we have 52 to select from. And second, now we have done the replacement, so we could again select out of those 12, right? Since the card which was drawn has been replaced, so that becomes our solution. Perfect. So you could simplify this particular answer, which will give you, both are, you can divide like this, 3 over 13 times 3 over 13, which is 9 over 169. Okay, so that becomes your solution. Now, in case the replacement is not there, in that case, the scenario changes a bit. So you get 12 over 52 as your choice. Now, if you have already drawn a face card, we are left with only 11, and total number of cards left are 51. So that is the scenario now. This could be simplified, and as you know, this goes 4 times 3, 4 times 13, and that 3 you could simplify here, 3 times 1 and 7. So that is your answer. So I'd like you to use the calculator, write down the answer as 11 over 13 times 17, correct? A pack of seed contains 40% red seeds and 60% yellow seeds, right? The probability that a red seed grows is 0.9 and that the yellow seed grows is 0.8. A seed is chosen randomly from the packet. Calculate the probability that the chosen seed is red and it grows. So we are looking for red and it grows, and the second is chosen seed grows, just grows, right? So you could do it in a couple of ways. We could have a tree diagram. So let's sketch a tree diagram first. So let's say we have starting with red and yellow. So for red, the probability is 40%, that is 0.4 is the probability. And for yellow, the probability is 60%. Correct. So that is the first choice. And then out of these, they may grow and they may not grow, correct? So they may grow or they may not grow. So that becomes the second thing, correct? Let me push this a bit. Now, it says that the probability that the red seed grows is 0.9. So it grows, let's say it grows, that is 0.9. That means it does not grow is 0.1. Correct? As far as the yellow seed is concerned, yellow seed grows is 0.8. So 0.8 to grow, so 0.2, it will not grow. Correct? Now if you need to find chosen seed is red and it grows, that means we are looking for this portion, red and it grows, right? So this answer. So it is 0.4 times 0.9. Perfect. So we can write this as 0.4 times 0.9, which is 36, with 2 decimal places, that is. Or in percent, you could write this as 36%. Correct? The other one is that the chosen seed grows. So when we say it grows, that means we are looking for what? We are looking for these two combinations. It could be red which grows and it could be yellow which grows, correct? So we are looking for that. So in part B, where we are saying that probability that it grows is what? Is red and it grows, which is 0.4 times 0.9, plus it is yellow that grows, which is 0.6 times 0.8, correct? So that gives you the answer. So let's find this out. So we have 0.4 times 0.9 plus 0.6 times 0.8, which is equal to 21 over 25, and in decimals it is 84%, right? So it is 84%. So that is how this question could be answered. So you could straight away also answer this question, or you could make a tree diagram as we did in this case to answer. Now the question is, of the 200 graduating students, 40 of them perform a musical and 22 perform a play. 12 students were in both. And we need to find probability of students performing in musical only and the probability that the students was neither in play nor in musical. So Venn diagram is a good option here. So let's make the two circles for the two groups of students. One which is performing in musical, the other one which is into a play. So what is given to us is that there are 200 in all, right? 40 of them perform in musical, 22 perform in the play, 12 students are in both. So this is critical. 12 students were in both. So we'll write this number 12 here right in the center. Now, if we say music, then in music there are 40. So 40 minus 12 comes here. So this group is 40 minus 12, correct? And the other group, 22 in all, is 22 minus 12, correct? So 22 minus 12 is 10, 40 minus 12 is 28. So that is the number of people who are involved into play or in the music. Is that clear? First part is, what is the probability of a student performing in the musical only? That means we're only interested in 28. Out of how many? Out of 200. So that becomes the solution, correct? Second one is, what is the probability that the student was neither in the play nor the musical? So clearly, out of 200, something here, right? So it is 200, take away, add all this. 28 plus 12 plus 10. Is it okay? So then you get your answer. So let's do it. So we have, well, you could do all this without calculator. Minus 28 minus 12 minus 10 equals to 150. Okay. So the answer here is 150 over 200 in all. Is it okay? So here we have 150 students which are neither in the play nor in the music. So I hope so far there is no problem. We have learned very simple examples to solve. We have also seen how to use tree diagrams and now the Venn diagram. So let's move on and learn few more concepts and move forward. Now we have three examples where we are going to use counting principles. The question here is, 7 teachers line up for a yearbook photograph. What is the probability that Anil will be in the center? They are in order of age. Assume no teacher is born on the same date. Anil and Ben are together. Now let's take the first one. There are 7 teachers. 1, 2, 3, 4, 5, 6, 7. And right in the center, that is the fourth position, we have fixed one person. Right? Now out of 7, how many ways are there for selecting each position? 1 has been fixed, 6 are left, and then 5, and then 4, 3, 2, and 1. So basically, you get 6 factorial ways. These are the favorable ways, right? Now, what are the total number of combinations? So in this particular case, what we see here is that in our sample space, since there are 7 to make a selection from, we have 7 factorial ways, right? Which you could write as a number. Let's use calculator. 7 factorial. Since this is going to be denominator for all, 5040. Now we are trying to figure out what are the favorable cases in each. So in the first one, we have 6 factorial ways. So this could be written as probability where Anil is in center. is equal to 6 factorial divided by total number of cases, which is 7 factorial, correct? So that gives you 1 over 7 as the answer. Perfect. Second, they are in the order of age. Okay, so that means the order could be either decreasing or it could be increasing. So that means there are two possibilities, right? So the probability for being in order could be equal to 2 over 7 factorial. Perfect. So we could write this as 2 over 5040, or 1 over, dividing this we get 2520. Correct. The last one here is Anil and Ben are together. Now, so we could group them, right? So we have 1, 2, 3, 4, 5, 6, 7. So let's group Anil and Ben. So we group Anil and Ben. So Anil and Ben has been grouped. Now remember, this could be also written in this form. So there are two ways of doing it. And since they have been grouped, we have 1, 2, 3, 4, 5, 6 places to choose from. Correct? So what we get in the numerator for this probability for a group of 2, we could write this as 2 times. I'm writing 2 times since we have A, B or B, A, right? Anil and Ben. The order could be changed. And since they are together, we have 6 factorial ways. All right, so here we have 6 factorial divided by total, is 7 factorial. Correct. So the answer here is 6 factorial over 7 factorial is 7. So we get 2 over 7 as our answer. So the probability for the last case when both are together is 2 over 7. Correct? So that is how we could actually solve this set of questions. Now let's move on and take the next. Now here is a very interesting question. There are 8 nurses, 10 doctors and 7 paramedics in an emergency ward. 5 of them are to be randomly selected to do a survey. What is the probability that there will be exactly 3 nurses and 2 paramedics selected? B is there will be at least 2 doctors selected. Now the key is that we are selecting 5 randomly, right? So 5 are being selected out of 8 plus 10 plus 7. Now it is a case of combination, correct? Since order is not important. It's a group. Correct? So as far as the sample space goes, the combination here is of 5 to be selected from sum of all this, 8 plus 10 plus 7. So 5 is to be selected from, let me write 10 plus 8 plus 7. Okay. So that is what it is. So basically the sample space has 25 C5. Correct? So that is the denominator for our cases. Now, let's look into what is the favorable. There will be exactly 3 nurses. So out of 5, 3 nurses and 2 paramedics. How many nurses are there? 8. So you are making selection. We could write also like this. Out of 8 nurses, you select 3 nurses. Right, that's the combination. So if I write like this, I don't have to write C. And if I do that, and I select 2 paramedics, these 2 paramedics are selected from 7. So 7C2. So that becomes the favorable cases divided by what we have here, which is 25C5. Correct? So that becomes the answer. So let's calculate. So we have 8 C3 times 7C2, and then we'll divide it by 25C5. What we get here is 28 over 1265, correct? So that becomes the solution for us. The second part here is there will be at least 2 doctors. Now when I say at least 2 doctors, it means what? It means that we could do 1 minus, we could do probability of at least 2 doctors. That means we could do 1 minus probability of no doctor, right? And also probability of 1 doctor. So we're left with at least 2 doctors. You get an idea, right? So that is how it should be solved, right? So it is 1 minus, right? So what we get here as 1 minus probability of no doctor. That means all 5 are selected from nurses and paramedics, correct? So what we have here is that all 5 are selected from nurses and paramedics, which is 15. So we have 15C5. That is what the selection is. Plus 1 doctor means that you select 1 doctor out of 10. So from 10 you select 1. But other 4 are selected from 15. So 15C4, correct? Divided by total number of selections, which is 25C5. So that becomes your answer. So let's calculate this now. So we get 15C5 plus 10C1 times 15C4, and then we are going to divide this number by 25C5, correct? So we get some number, and we have to take all this away from 1, right? So I'll do 1 minus, not write negative. So basically what we have got here is 1 minus 793 over 2530. So I'll do minus 1, and I get equal to 1737 over 2530. So that becomes the answer. If you have to write in percent, you could convert this to decimals, and you get approximately equal to 68.7%. Correct? So that is how you could answer this question. I hope the steps are absolutely clear. Slightly complicated. Take your time to understand how we did at least 2. That means there could be no doctor or 1 doctor, and those cases we have taken away. Perfect. So that is how we did it. So this is what we took away from 1. Now here is a bonus question. A family of functions is given by f of x equals to x squared plus 3x plus k, where k belongs to 1, 2, 3, 4, 5, 6, 7. One of these functions is chosen at random. Calculate the probability that the curve of this function crosses x-axis. Right. So I hope you are reminded of quadratic equations. So we're looking into quadratic equation, right? When you say crosses x-axis, we are looking for real roots. That means we have to analyze b square minus 4ac, and that has to be greater than or equal to 0, right, for real roots. It has to cross, perfect. So let's see. In our equation, we have f of x equals to x squared plus 3x plus k. So in this case, what we know is a equals to 1, b equals to 3, and c equals to k. So calculate b squared minus 4ac, which is, b is 3, so it is 3 squared minus 4 times 1 times k, which is 9 minus 4k. Now the equation is that 9 minus 4k should be greater than 0, right? So that means 9 should be greater than 4k, or k should be less than 9 over 4. Perfect. So that clearly shows that 9 over 4 is 2 point something, right? So 2 point, let's say 25, right? So 4.28, 10, 2, right? So like this. So k has to be less than 2. So that means only possible values of k are 1 and 2. Do you get an idea, right? So we are saying k is less than 2.25, right? So the possible values for k are 1 and 2. So now you can actually answer the question very easily. It is 2 out of 7. There are 7 choices, out of which first 2 work in the given scenario. So with that, we come to an end of an excellent test question on probability. I hope you find it useful. Feel free to write your comments and share your views. And if you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.